In this section, we're going to be talking about solving inequality equations. So for example, an equation of this form. Let's see if we have 7x minus 3 is less than 2x. And we kind of solved something like this in a previous video, but we're going to be taking a look at a lot more examples of types of equations like these. And for the most part, this sign right here can just be thought of as an equal sign. And just like before, how we want to get x on one side and everything else on the other side, that still applies. And yeah, again, for the most part, we can think of this as just an equal sign. So this doesn't really change. We could still, just to solve this one, let's say we want to move the x's over to the left. So we could start just by subtracting 2x on both sides. Here we're going to have 7 minus 2, which is 5. We still have our minus 3. And here the 2 minus 2 go away, so we have a 0. Then we could take this 3 and add it to the other side. So we just have a 5x on this side. Those 3's cancel. We still have our sign, and then we're adding 3. And then we can divide by 5 on both sides. So x is less than 3/5. So in this example, you saw that this sign, if we replace the sign with an equal sign, the same work would follow. The only thing different about this sign is that, we'll see this in the next example. If you end up dividing both sides by a negative, this sign needs to flip around. So what I mean by that, say if we had something like this. Here's just a little quick example. Minus 5x is less than 3. So pretty much like we had this step right here. The 5x is less than 3. Suppose that was a minus 5x is less than 3. And we want to solve for x. So just like if this was an equal sign, we would divide both sides by the minus 5. Okay, let's do the work. So this side, those 5's cancel, so we just have an x. But like we said a second ago, whenever we divide by a negative on both sides, here we're dividing by a negative 5. The sign needs to turn around. So now it's going to turn this way, and we'll have minus 3 over 5. This only happens with division. So for example, we didn't do this on this side, but say we could subtract a number on both sides. That's fine. The only time that this sign is going to turn around is if we divide by a negative. Other than that, the sign always is going to stay in the same order. So if you saw on this side, we did all these manipulations. Like right here, we subtracted a 2x on both sides, but still the sign stayed the same. Here we added a 3, the sign still stayed the same. And here we're divided by a positive number, so the sign still stays the same. The only time the sign is going to switch around is when we divide by a negative, like we did in this example. So the next example, we have minus 5 less than 6 minus 2x less than or equal to 1. So in this problem, which is different from the previous two only had one inequality sign. So here's just one sign, here's one sign. This one has 2 signs. We have one right here and we have one right here. So the goal for these problems is to get x in the middle and then numbers on the other side. Whereas the goal before was just to get x on one side and a number on the other side. When we have 2 signs, we need to get an x alone in the middle, so we have to manipulate this to make that happen, and then there'll just be a number over here and a number over here. So right now there is an x in the middle, but we also have this 6 and we have a minus 2 in here, so we have to find out a way to get rid of both of those numbers. So let's start by getting rid of the 6. So we can subtract 6 in the middle, subtract 6 on the left, subtract 6 on the right. Over here we're going to have minus 5 minus 6, which is minus 11. And again, the sign's not going to change because all we did was subtract a number. The only time the sign changes is if we divide by a negative number. Okay, so these 6's in the middle cancel, so we just have our minus 2x. We still have our sign over here, and now we have 1 minus 6, which is minus 5. Okay, so now the last thing to do to get x alone is we have to get rid of this minus 2, so we have to divide by minus 2 everywhere. Okay, see, but we're dividing by a negative, so now all these signs are going to turn around. So here, these minuses cancel. We just have 11 over 2. This sign turns around. These 2's cancel, so we just have our x. This sign turns around, because again, we're dividing by the negative. These minuses cancel, and we just have 5 over 2. Okay, so this would be, let's turn this into interval notation. This doesn't really have a name, this type of notation, but if we want to put an interval notation, let's do both. Let's do graph notation and interval notation. So let's first by putting this onto like a little number line. So what is it telling us? X is bigger than or equal to 5 over 2, and x is less than 11 over 2. So here's 5 over 2. Here's 11 over 2. And we know that whenever there is a greater than or equal to sign, that gets a closed dot. So this 5 over 2 is going to get a closed dot. And this is just a less than sign. So there's no equal to part. So that means 11 over 2 gets an open circle. So now we need to figure out where are we shading. So what does this tell us? Well, this is saying x is less than 11 over 2. Less than means the left. So we have to start shading to the left of 11 over 2. But at the same time, this is saying x is bigger than or equal to 5 over 2. So bigger than 5 over 2 means we shade to the right. So this is really just saying we're bigger than 5 over 2, so to the right, and less than 11 over 2, so to the left. So it's everything in between. So this range right here, this is just these numbers. And if we were going to put this into interval notation, so we're going to have a bracket on 5 over 2 because it's a closed dot, all the way up to 11 over 2, which because that's an open circle, we put a parenthesis on it. So this would be, the graph notation. And this would be interval notation. Okay. So the next couple of problems that we're going to do, we want to solve. So what we're going to be solving now, before let's do a problem, is sort of like what's the general form that we're going to be solving. Pretty much it might look something like this. We're going to have ax squared plus bx plus c on top, and then on the bottom, dx squared ex plus f. And then this can be any sign, a less than, a bigger than, less than or equal to, greater than or equal to, and then a number over here. So usually 0. For all these examples, it'll be 0. So we're not going to solve this one, but let's just do an example of what this could look like. Maybe something like x squared minus 1 all over x plus 2, bigger than or equal to 0. So this one is of this form. So you see this top, here the a would be 1. We have 1x squared. There's no x term, so this b would be 0, and this c would be minus 1. Here on the bottom, we don't have an x squared term, so this d would be 0. We have just only a 1x, so this e would be 1. And here's a 2, so our f would be 2. So this one is of this form. So now we want to learn how do we solve equations that look like this. And so there's going to be a sequence of steps that we always are going to solve. And the first step is going to be to factor the numerator and factor the denominator. So let's say factor the top and bottom. So once we factor the top and the bottom, we want to find the zeros of the top and the bottom, meaning we want to just set the top equal to 0, set the bottom equal to 0, and see what x values we get. So let's find, which we'll call the top zeros and bottom zeros. Okay, so we want to find the top zeros and factor the top and the bottom, and then find the top zeros and the bottom zeros, which means we just want to set the top equal to 0 and solve for x, and then set the bottom equal to 0 and solve for x. And then once we do this, we're going to put these, so whatever we find in this section, these x values, we're going to put those onto a number line. So put the zeros. The zeros are the x values we find in this step. So put the zeros on a number line. And then this last step, we're going to be calling it test points, which we'll see with an example what this means. So let's just apply all of these to this problem up here. So the first step says factor the top and the bottom. Okay, so this is x squared minus 1. We have to factor this. So we saw in a previous video, let's not worry about formulas. If we want to factor this, let's do this down here just off to the side. So notice when we want to factor, we look at the x squared, and if there's a 1 in front of it, which it is in this case, the first thing we do is just draw 2 sets of parentheses, put an x, and then we put an x. And when there wasn't a 1 in front, like if there was a 5 in front, we would have to use the AC method. Okay, so now what are we looking for? Let's rewrite this as x squared plus 0x minus 1. So remember when we're factoring, we want to look for numbers that multiply up to this last number but add up to this middle number. Again, 0x is just 0, so this is the same thing. So we want to find what are numbers that multiply up to -1 but then add up to 0, and this is going to be +1 -1. Since 1 times -1 is -1, and if we add these two numbers together, we get 0. So this factors into this. So when the first step it says factor the top and factor the bottom, we can factor this top as x plus 1, x minus 1. And then the bottom we can't factor. We're just going to leave it as x plus 2. Okay, and we still have bigger than or equal to 0. So there's the first step. The second step is to find the top and bottom zeros. So that means we just take our top, x plus 1, x minus 1, set it equal to 0, and we take our bottom and set it equal to 0. Okay, this one's easy. This just means we set each of these pieces equal to 0, so we get x plus 1 is 0, x minus 1 is 0. Here we're going to get x is going to be -1, and here we're going to get x is going to be +1, and here we're just going to get x is going to be -2. So these are our 3 zeros. So in this step where it says put the zeros on a number line, these are the numbers that we're going to be putting onto our number line. Okay, so here's our number line. We have -2, -1, and +1. So now something we didn't write over here is we have to figure out, do we want to put open circles or closed circles on these points? So let's start with the bottom zeros. We know that the bottom of a fraction is never allowed to be 0. So when we set their bottom equal to 0 here, so when we get x, so here's the bottom, x plus 2. We set that equal to 0, we see x is going to be -2. So this -2 has to have an open circle. And that's because anytime we have a bottom 0, we put open circles on that for the reason that we're not allowed to have this bottom be 0. We know if we plug in -2 to this equation, we'd get -2 plus 2, which is 0, which means we'd have a 0 in the bottom of a fraction, which we can't have. So we're going to get rid of that number by putting a circle on it. Now the top zeros have to do with this sign. This is the problem we're solving. If this is has the or equal to part, so this is a greater than or equal to sign. If we have that or equal to sign, we're going to be putting closed circles, no matter what, on the top zeros. In the next example, we'll do one where this wasn't an or equal to sign. So if this was just like a greater than sign like this, the top zeros would also have open circles. But because there's this or equal to part, we have closed circles. Okay, so this takes care of step 1, 2, and step 3. So now we have to go to step 4, test points. What this means is the first thing we want to do is just pick a number in each of these sections, in between the dots. So for example, a number in this section, a number to the left of -2, we could choose -10. A number in between -2 and -1, we could choose -1.5. A number in between -1 and 1, we could choose 0. And a number bigger than 1, we can choose 5. And so now what we're going to do is we want to take this equation, everything right here when we factored everything. Let's write it down over here again. Okay. And so what we want to do now is we're going to take these numbers and plug them into this equation, and we only care if it's going to be a positive number or a negative number. So let's start with -10. If we plug -10 into this equation, so again, we don't really care about what these numbers are. Let's just, all we care if it's a positive or a negative number. If we plug in -10 right here, we get -10 plus 1, which is -9. So that's a negative number. So let's put a minus sign here. If we do -10 minus 1, that's -11, so another negative number. And if we do -10 plus 2, that's -8, so another negative number. So here we have two negatives on the top and a negative on the bottom. So if you did a negative times a negative, that'd be a positive. And here we'd have a positive divided by a negative, which is negative. So this number right here is minus. So up here, we're going to put a minus sign. Okay, now let's do the same thing with 1.5. Or 1 minus 1.5. Okay, if we plug in -1.5 here, we're going to get a negative. If we plug in -1.5 here, we're going to get a negative. And if you plug in -1.5 down here, we're going to get a positive. So these two negatives make a positive, and a positive divided by a positive is a positive. So we're going to put a plus sign right here. Just off to the side. Now we have to do the same thing for 0. Let's put this over here. If we plug in 0, we're going to get a positive here, a negative here, and then a positive here. Okay, so this is going to give us a negative. Now over here on the 5. Sorry, we're kind of running out of room. But we plug in 5, it'll have positive, positive, and positive. And then if we do positive and positive divided by a positive, we're going to get another positive number. Okay, so now we're pretty much done. After we test the points, we see that on this number line that we made, we have some minus signs and some plus signs. So now we have to go back up to the original problem. What do we want? Well, we want our thing to be bigger than or equal to 0. So bigger than or equal to 0, those are all positive numbers. If this was less than or equal to 0, we'd want negative numbers. But since this says bigger than or equal to 0, we want all the positive sections. So here's a positive section. We're going to shade this one in. This is a negative section. Negative does not mean bigger than or equal to 0. All the numbers bigger than 0, those are positive. So we're going to shade this positive section, not this minus one. We're going to skip this minus one. And then we're going to shade this positive section. So the answer is everything we just shaded. So let's write what we shaded. We have -2 to -1 with a parenthesis on -2. Sorry, we're going to put a bracket on -1 because it's a closed dot. So a parenthesis on -2, a bracket on -1, then the union symbol, and then we're going to have 1 all the way up to infinity. Okay, so then this answer right here, this is going to be all the x values. So any x value we choose in here, in one of these intervals, if we plug it in, it's going to make this number bigger than or equal to 0. Okay, let's do one more example like that, just a little bit different. So let's do x squared minus 5x minus 24 is less than 0. Okay, so if you look back at those steps, the first step was factor the top and the bottom. So first, let's just look at this. We don't really have a bottom, but we can write this as this whole thing divided by 1. So this could be the top and this could be the bottom. So let's start by factoring the top. So we have a 1 in front of our x squared. So if we want to factor it, let's put this over here. We know we just make 2 sets of parentheses. Put an x here, put an x here. And now we want to find numbers that multiply up to -24, but then add up to -5. And so that's going to be -8 plus 3. Since -8 times 3 is -24, -8 plus 3 is -5. And then nothing to do to factor 1, just 1. Okay, less than 0. So now we've done the first step. We factored the top and the bottom. The second step is now to find the zeros on the top and the zeros on the bottom. So let's start with our top zeros. Okay, so just set the top equal to 0. Okay, so now set each of these pieces equal to 0. Here we get x is equal to 8. And here we get x is equal to -3. All right, so now for the bottom zeros. We set the bottom equal to 0. The bottom is just 1. But if we set this equal to 0, this is never going to equal 0. 1 is never equal to 0. This is always just going to be 1. So the bottom is never going to be 0. So in this situation, there are no bottom zeros. There's nothing to worry about there. Okay, so once we find our zeros, we go to our number line and put all the zeros on a number line. So we have 8 and -3. Okay, so when we remember in the previous example, the bottom zeros, no matter what, got open circles. Here we don't have any bottom zeros, so don't have to worry about those. But we have these top zeros, and these can be open or closed, and we have to look at our sign. Our sign is a less than sign, not a less than or equal to. Because it's a less than sign, these need to be open circles. So again, this is the top zeros only have closed circles if this sign has the or equal to part on the bottom of it, which this one does not. Okay, so we put our zeros on a number line. Now we have to do the step where it says test points. So pick a point here, pick a point here, pick a point here. Something to the left of -3, we can choose -5. In between -3 and 8, we could choose 0. And bigger than 8, we could choose 10. So now we're going to take our the version that's factored. Let's just rewrite it. X minus 8, x plus 3 over 1. Now we're going to plug in minus 5 to this. If we plug in minus 5, we're going to get a negative up here, a negative right here, and the bottom is always positive. So these two negatives make a positive, and we're dividing by a positive, so that gives us a positive. So in this section, we're positive. In the middle, we chose 0. Plugging in 0 here, we're going to get a negative. Plug in 0 here, we get a positive, and the bottom's always positive. So this gives us a negative, so we're minus in the middle. Now 10. We'll have a positive here, and then a positive on the bottom, which gives us a positive. Okay, so we're done with that, and now we need to see back to our original problem. What are we looking for? Well, it's telling us we want less than 0. So less than 0 means negative. So the only negative section we have is in this middle. All right, so there's the region we want, and if we put that into an interval, it'll be minus 3 all the way up to 8. Okay. And the last examples we'll do from this section are going to be inequalities that have to do with an absolute value. So before we start this, absolute So for example, we have two situations. The absolute value of something, we'll just call x, say being less than a number, which we'll call a, or the absolute value of x, just whatever's on the inside, being bigger than some number. And these can be less than signs, or they could be less than or equal to signs, it doesn't matter. So how we solve this one is if we have this situation, the absolute value being less than a number, this is going to mean minus that number, less than or equal to x, and less than or equal to that number. This one over here is going to be x is bigger than or equal to this number, or x is going to be less than or equal to minus of that number. So when we're dealing with absolute value inequalities, again, we only have one of two situations, either this situation or this situation. With this situation, that means we have to solve this, and with this situation means we have to solve this. So let's do one of each of these. Let's solve the absolute value. Say we have 2x minus 3 is less than or equal to 7. So again, this is the absolute value of something is less than or equal to a number. So less than or equal to a number. So that means we're going to do this. We're going to take the negative number, which is negative 7, less than or equal to just x. X is the inside of the absolute value. So the inside of this absolute value is 2x minus 3. Then less than or equal to the positive, this is the regular number, so 7. So now we need to solve this. So we start by adding 3, just because remember we want to get x alone in the middle here. So we're going to add 3. Here we're going to get minus 4. 3's cancel, we're just going to have a 2x. Adding 3, we get 10. And the last thing to do is divide by the 2. And here we're dividing by a positive number, not a negative number, so the signs stay the same. Over here we're going to have a minus 2. In the middle, we're going to have an x. And on this side, we're going to have a 5. And if this was going to be into an interval, this is x is bigger than or equal to minus 2 and less than 5. So minus 2 all the way up to 5. Okay, so now let's do an example that does this one. So how about like 3 minus 3x is bigger than or equal to 12. Okay, so here we have the absolute value of something bigger than a number, which is this. The absolute value is bigger than a number. So that means we have these two things. The inside is going to be bigger than the number, so the inside being 3 minus 3x is bigger than or equal to 12. Or this one, the inside being less than the negative number. So this whole inside, 3 minus 3x is less than or equal to minus 12. So let's solve both of these separately. Here we could subtract the 3 over. So minus 3x is bigger than or equal to 9. Divide by the minus 3. So the x is just an x on this side. We're dividing by a negative, so the sign turns around. This needs to be a minus 3. And 9 divided by minus 3 is minus 3. Okay, so or. Now again, let's start by subtracting the 3 over. So we're going to get minus 3x is less than or equal to minus 15. Divided by the minus 3. Here the 3's cancel. The sign turns around because we're dividing by a negative. And 15 divided by, so minus 15 divided by minus 3 is 5. So let's go on a number line. What does this mean? We have two things. First, here's a minus 3. Here's a 5. We have greater than or equal to signs, so both of these are going to get closed dots. This is telling us that x is less than or equal to minus 3. Less than means we go to the left. Okay, this is x is bigger than or equal to 5. Bigger than means we go to the right. So this is our shaded section. And if we're going to put this into an interval, this means minus infinity up to minus 3. Minus 3 with a bracket because it has a closed dot, and infinity always has a parenthesis. No, union 5 all the way up to infinity. And this would be the answer for this one.